Okay, so we will first start with step 4, which is calculating the surface tension factor FST in short. So how do we manage to get the FST? So first of all, we'll need the surface tension value, divide by 20, and then power to zero point 0.2. Okay, so how do we get the surface tension value? It is part of the information being extracted from Aspen based on the question provided. So for example, Um, the surface tension value here is 86.12 dyne per cm. So we just input the value and then divide by 20, then power to zero point 0.2. So we managed to get a value of 1.339 for FST. So next we'll proceed with the flow ratio parameter. So the flow ratio parameter FLG will be the liquid flow rate divided by the gaseous flow rate and then multiply with the density of gaseous state over the density of liquid state, then power of zero point 0.5. So these four parameters can also be collected from Aspen and or extracted from Aspen and then just input the values. So according to the values for the four parameters mentioned just now, so we managed to get 2.239 for FLG. And take note, flow ratio parameter is dimensionless. Next, you need to obtain the CSB value from figure 13.4 of Product and Process Design Principles book. So the CSB here has a unit of feet per second. So how do we manage to get the CSB? So as you can see here in the diagram, we have the plate spacing, we have the value of FLG. So by collecting these two values, we managed to determine the CSB graph based on the graph. Okay, so first of all, we need to assume the plate spacing. So for example, let's take 24-inch of plate spacing. So by having this parameter value, next we need to have the FLG. But we managed to get it already, right, in step 5. So the FLG unit is 2.239. So but you can see here in FLG, it's already maximum, it's only 2. So we just plot here, then plot with the 34-inch plate spacing. Then by the graphical method, you manage to get a CSB value of 0.06 feet per second. So depend on the unit provided or required by the question. So we might need to do certain conversions based on the unit required from the question. So yeah, just take note lah. Then next we'll proceed with the capacity parameter. So according to the formula, the capacity parameter is the CSB multiplied with the FST multiplied with the FF and also FHA. So we already have the CSB just now here in step 6. We also have the FST in step 4. Then what about FF and FHA? FF is the foaming factor, while FHA is the whole area factor. So for these two parameters, FF and FHA, you need to check for the question the information, whether the information is provided or not. So for foaming factor, there are two different scenarios or different conditions. So if the question mentioned is a non-foaming system which is a typical distillation, then the foaming factor value will be 1. If it mentions that the system is foaming system, which is the adsorption with heavy oils, then the foaming factor will be around zero point 0.5 to 0.75. Next, we'll proceed with the whole area factor. So for whole area factor wise, if it is valve and bubble cap trace, and it will be having a FHA value of 1. If it is sieve trace for a ratio of AH over AA greater than 0.1, whereby it mentioned here AH is the total area of a tray, while AA is the active area of a tray. So if the ratio of AH to AA is greater than 0.1, then it will be having a value of 1. If the C trace for value is between 0.06 to 1.0, then it will be having a formula of the ratio of AH to AA over AA multiplied by 5, and then then addition another 0.5, then you'll get the FHE value. So I take an example. If the question provided is a non-foaming system, and then having a sieve tray value of having sieve trace, and then the ratio of AH to AA value is 0.15, for example, then both values are both values of FF and FHA will be 1. So we already have the CSB in step 6, and also we have the FST in step 4. So by inputting the values, we can get a value of 0.02448 meter per second. So why there's a meter per second? So in step 6, we need to make a conversion of 0.06 feet per second to meter per second. So there's a conversion here. Next, we'll proceed with the flooding velocity. So flooding velocity will be the capacity parameter multiplied with the difference between density of liquid and density of gas, then divide by the density of gas, then power of 0.5. So by inputting the values from Aspen and also the value of capacity parameter obtained from step 7, we managed to get a flooding velocity of 0.25 meter per second. And also take note, it might also require, from depends on the question itself, it might also requires different units. So we also might need to do different conversions. So depends on the question itself. So we'll proceed with. So if I wish to convert to feet per hour, then it will be 2,949.74 feet per hour. If I wish to convert to meter per hour, then it will be 899.0801 meter per hour. Okay, so next we'll proceed with step 9. So step 9 will be the tower inside diameter calculation. So according to the formula, it will be having so we need to multiply the gaseous flow rate with 4, and then divide with the flooding factor, multiply with the flooding velocity, and then multiply with pi, multiply with 1 minus AD over AT, and then multiply with the density of gaseous flow rate, density of gases, sorry. Then power of 0.5. So how do we manage to get the value of AD over AT? So according to this image, if we wish to determine the AD over AT, we need to understand the value of FLG. So different ranges of FLG, you get a different formula to calculate the AD over AT. So by understanding in step 5, FLG is 2.239. So if it is greater than 1.0 as shown here, the value of AD to AT will be 0.2. So the value will be 0, 1, 2. Then for floating vector wise, this value can be assumed, but usually is between 0.75 to 0.85. It depends on the assumption itself. So by having all the values, we just input all the values, then we manage to get a value of 1.644 meter. It also depends on the unit required. If we wish to convert to inch, it will be 64.74 inch. If we wish to convert to feet, then it will be 5.395 feet. Okay, so next we'll go with the calculation of height of the tower. So for height of the tower, we have a formula of trace spacing multiplied with the number of trace minus 1 plus the top height plus the bottom height plus the feet trace spacing plus the skirt. So for the number of trace, we can obtain from step 2. So in C62. So as calculation earlier, this will be in step 2 you will need to calculate the number of trace. Then by having this value, then how about trace spacing? We also already assume right in step 6. So early possible, as early mentioned, the trace spacing already assumed as 24 inch, for example, just now. Then for the top and bottom, usually we have a fixed value, which is 4 feet for top height and 10 feet for bottom height. So these two values are usually fixed. So by having all these values, we will just input here into the formula. So we managed to get 1220.84 inch. It also depends on the unit required. So if convert to feet, then it will be 101.7369 feet. If wish to convert to meter, then it will be 31.0094 meter. Yeah, so usually for this part will be usually the calculations required will be calculating these two things or these two units at last. So usually it requires the tower is a diameter or requires the height of the tower. Okay, I think that's all already. I'll pass to the next person.